Hey folks, so this is the first video in section 8.5. We're going to start tying together the concept of polar form with complex numbers. Now you'll remember back in the previous math class, if you went to my school, this is Math 110, college algebra, we had to work with complex numbers, a plus bi. So we're going to be tying together our polars, r's and thetas, with our complex numbers, a plus bi. All right, so let's take a look at this complex plane. If I wanted to graph a number such as 2 minus 3i, we can actually modify our regular old coordinate system by calling the horizontal axis the real axis and the vertical axis the imaginary axis. Once I do this, notice that my picture here, we went to the right 2 because that's the real part, and we went down 3 because that's the imaginary part. Then, because this allows us to graph, notice that these complex numbers called a plus bi, it's a position vector. It has the initial point at 0, 0, and its terminal point is at the coordinate AB, or we could call it XY. Here's just a reminder about the fact that in our brain we're splitting everything between legs and r's and thetas. So we have two sides of the brain. Just understand we've got the rectangular side and we have the polar side. All right, this representation, a plus bi, is called rectangular form. So understand, anytime you're asked for rectangular form, you are being asked for a plus bi. This is also known as the standard form. So if you see rectangular or you see the word standard, your brain should say, oh, I'm on the leg side. Now, let's take a look at some of the things that I can do with our complex numbers. We'll start out pretty easy. This one says to find the sum. So we're adding two complex numbers. So simply add the real parts, add the imaginary parts, and you get -2 plus 5i. All right, now polar form. So we have rectangular or standard form automatically means legs. Polar form, we understand, is going to be r's and thetas. So what's the relationship then among our x's and y's versus our r's and thetas? We've got several different equations that we've already used. These two we used in the last section. This is the Pythagorean theorem. And this is just SOHCAHTOA, the TOA part of SOHCAHTOA. So what we find here is that the polar form, also known as the trig or the trigonometric form of a complex number x plus yi or a plus bi, is this guy right here. This is the polar form. And you say, how in the world do you get that? So let's take a look over here at something that I have written down. A plus bi is my rectangular form, something we're comfortable with already because of previous classes. Well, what if I substitute, since I have the equation that says A equals R cosine theta and B equals R sine theta, let's just substitute. Notice that now I have these two terms and I have a GCF of R. So let's factor out the R, and I now have R times the quantity cosine theta plus I sine theta. And that is exactly what we have right down here. R times the quantity cosine theta plus I sine theta. So that's an easy way then to show how to get from the leg or rectangular or standard form to the polar or the trigonometric form. Now, there is a shortcut or a shortened version, an abbreviation that we can use. Notice here that cosine plus I sine is sometimes abbreviated cis theta, CIS. Cosine I sine is what the abbreviation is there. And so if I use this notation, then my polar form would be R cis theta. You do need to be comfortable with both the long version as well as the abbreviated version, because you will see both of those in my lab. All right, example number 2 here. Let's convert from trig form, okay, that's r's and thetas, two rectangular forms. So what's given, we just mentioned, are r's and thetas. What's wanted, we want rectangular forms, so we want legs. Okay. So whenever you have r's and thetas and you want legs, you're going to simply simplify. Simply simplify. All right, so this is straight off of the unit circle here. 135 degrees is smack dab in the middle of the second quadrant. The cosine value there is negative root 2 over 2. The sine value is positive root 2 over 2. So you'll notice what I've done here. The 10 stayed put. Cosine 135 is negative root 2 over 2. I left the I there. Sine 135 is positive root 2 over 2. Now I'm going to take my 10 and I'm going to distribute. So again, I'm simply simplifying. And that's going to give me negative 5 root 2 plus 5I root 2. Yes, I always get the question, is it proper to write 5 root 2I? Yes, that is proper. However, if your handwriting starts to look like that I is a little bit underneath, then you may get some points taken off. So just be careful about that. All right, so when I'm converting between rectangular and polar forms, okay, so remember, rectangular is legs, trigonometric or polar form is r's and thetas. Step 1, sketch a graph. So if you think about past videos, I keep saying whenever you have legs, draw a picture. Well, that's exactly what this is saying. Sketch a graph, draw a picture of the legs. Find your radius by using Pythagorean theorem. No big deal there. And find your theta by either using the unit circle, use sine or cosine, or use the equation tangent inverse of the opposite over the adjacent. Any of those three will do just fine. I would use these two if these are unit circle values. I would use this one when I have to use my calculator. Why is it important to choose the correct quadrant for theta? That is so that you can make sure that you have the positives and negatives all in your proper positions. All right, example number 3. Notice that it says write each complex number in trigonometric form. So you look at this. I have legs. I want trigonometric form. I want polar form. I want r's and thetas. So I've already drawn it for you. When you have legs, draw a picture. Already drawn it for you. I'll use the Pythagorean theorem to get my radius, which is 8 root 2. My theta here, I am not using tangent inverse. You could, but honestly, it's just as easy to think, hey, what in the fourth quadrant has identical x and y values? Oh, well, and it does say, by the way, that we're supposed to be using radians here. 7 pi over 4 does. Or you could even say negative pi over 4 does. You're not given a restriction, so you could use either one of those. And so this says to write in trig form. Now, we've got r and theta, but we haven't written in trig form yet. So remember, this is where we have r times the quantity cosine theta plus I sine theta. So you can either write that 8 root 2 times the quantity cosine 7 pi over 4 plus I sine 7 pi over 4. Or you could use the abbreviated version, 8 root 2 cis 7 pi over 4. And just for the record, everywhere that you see the 7 pi over 4, you could have also had a negative pi over 4. All right, for part B, same set of directions. The difference is that we are using degrees here. So notice that I have this negative 15, but it doesn't really look like a plus bi. So the first thing I'm going to do is I'm going to write it as a plus bi so I don't get myself confused. And then I'll go ahead and draw it. So this is negative 15, and then there is no imaginary, so there is no up and down value. All right, so coordinate here is negative 15, 0. So my radius is 15, my theta is 180. You say, how did you get that? I just used unit circle values for the 180. And then I can go ahead and write that in polar form. Okay. Write each complex number in its alternative form using calculator approximations as necessary. All right, so, and I've written over here just a little review. anytime you're given legs, draw a picture. Anytime you're given polars, simply simplify. All right, so when you take a look here, you're given polars. So, but 205 degrees is not on the unit circle, so we'll need our calculator for this. So let's go ahead into the calculator. Let's type in what is the cosine of 205, what is the sine of 205. And then we'll take our 7 and we will distribute our 7. And this is my, it says write the complex number in its alternative form. So if it's a trig form, write it as a rectangular form. If it's rectangular form, write it in trig form. Mine was in trig, so now I'm writing it as rectangular. Notice here I have legs, I have rectangular. So anytime you have legs, draw a picture. So that's what I have first. Use the Pythagorean theorem here to find my radius. Now, this is not a unit circle, normally memorized value, so we'll go ahead and use our calculators. We'll use that tangent inverse of -2/7. That's going to give us -15.94. Unfortunately, that does not match up with our picture because -15 degrees is down here. So I need to add half a circle. I need to add 180 degrees to get up to the second quadrant. And that'll give me 164.0546 degrees. But that's not my trig form. So my trig form then would be R times cosine theta plus I sine theta, or R cis theta. So that's where I get that root 53 cis 164.0546. All right, I'm going to stop the video here and pick up with a second video.